Dear learners, Assalamu alaikum. Welcome you all to this class. Dear learners, open YouTube, write for search, F. Rahman Academic channel, logo after search. This is my logo. Just click on my logo and open my channel and choose your video. Dear learners, please subscribe my channel after watching. This will certainly inspire me for uploading the next video. Our today's topic is equation and subtopic is nature of the roots of a quadratic equation of one variable. Introduction. Dear learners, at the end of this class, you all will be able to 1. Have necessary ideas about the number system as prior knowledge. 2. Find the nature of the roots of any quadratic equation of one variable. Prior knowledge. Integers or integral numbers. Any whole number, negative, 0 or positive, is called an integral number. As for example, -3, -2, -1, 0, 1, 2, 3 are all integral numbers. -3, -2, -1 are negative integers or negative integral numbers. 0 is neutral integral number or integer. 1, 2, 3 are positive integral numbers. Rational numbers. Any number which is expressible as the ratio of two integers is called a rational number. As for example, -3, -3 by 2, -1, 0, half, 2, etc. are all rational numbers. -3 is a rational number as -3 can be expressed as the ratio of -3 and 1. The same way, all integral numbers are rational numbers. Irrational numbers. Any number which is not possible to express as the ratio of two integers is called an irrational number. As for example, -√3, -√2, √5, √32, -1 plus 1 is √3 by 2, etc. are all irrational numbers. It is required to mention that if an irrational number is expressed in the form of decimal, the number of distinct digits after the decimal point will be infinity. And then real numbers. Rational and irrational numbers are together called real numbers. Perfect square numbers. A number which is the product of two equal numbers is called a perfect square number. As for example, 4, 9, 25, etc. are all perfect square numbers because 4 is the product of 2 and 2. 9 is the product of 3 and 3. And 25 is the product of 5 and 5, and so on. Complex imaginary numbers. Any number of the form a plus ib is called a complex number, where a, b are real numbers and I is equal to square root of minus 1. And ib is called an imaginary number or imaginary part. As for example, minus I minus square root of 2i, 1 plus I, 3, etc. are all complex numbers. And 3i minus twice I, 5i, etc. are all imaginary numbers. All imaginary numbers are complex numbers, but all complex numbers are not imaginary numbers. Such as 3. 3 is not an imaginary number. Every real number is itself a complex number, but not imaginary number, except 0. Main speech on the topic, the roots, say x1, x2 of the quadratic equation ax square plus bx plus c is equal to 0 are x1 is equal to minus b plus square root of b square minus 4ca by twice a, and x2 is equal to minus b minus square root of b square minus 4ca by twice a. We have already discussed and obtained these roots in our previous class. However, if we let d is equal to b square minus 4ca, then the roots of the quadratic equation become x1 is equal to minus b plus square root of d by twice a, and x2 is equal to minus b minus square root of d by twice a. A question may be arisen in you, why is b square minus 4ca considered as d? B square minus 4ca is within the square root. That's why it is an important factor to determine the state and nature of the roots of the quadratic equation. And that's why it is called the discriminant of the quadratic equation. Just go through. We can easily determine the state and nature of such roots by d is equal to b square minus 4ca. That is why it is called the discriminant of the quadratic equation. It is to remember that the nature of the integral roots can never be obtained by d. We have discussed it in our previous class. You all are requested to see the previous class. The possible values of d will be d less than 0, d is equal to 0, or d greater than 0. In case of d greater than 0, we should consider whether d is a perfect square or not. That's why we should consider the following 4 cases. Case 1, if d is 0, Then the roots are x1 is equal to minus b by twice a, and x2 is equal to minus b by twice a. If we put here d is equal to 0 and d is equal to, then you will get d is equal to. They are equal. If a and b are real, then we can easily write which are equal and real roots. If a and b are rational, then we can also write which are equal and rational roots. Case 2, if d greater than 0 and d is not a perfect square. If d is not a perfect square, then the roots can never be free from square roots. In either case, these two roots should be irrational. That's why you can write, then the roots of the equation are unequal and irrational roots. And these, if these two roots are irrational, they are called conjugate irrational roots because they differ only by plus and minus sign. Just we put the radical sign, square root. That's why you can write irrational conjugate roots appear in pairs in an equation. In particular, if a plus square root of b is an irrational root of the quadratic equation px square plus qx plus r is equal to 0, then a minus square root of b will be the other root of it. Such as if 2 plus square root of 5 is an irrational root of a certain quadratic equation, then the other root of it will be 2 minus square root of 5. Case 3, if d greater than 0 and d is a perfect square, let d is equal to k square, where k belongs to q, set of rational numbers. Then the roots are x1 is equal to minus b plus k by twice a, and x2 is equal to minus b minus k by twice a. Just put this value of d. Then we will get these values. If a and b are reals, then we can write which are unequal and real roots. If a and b are rational, since k is rational, that's why in either case we can write which are unequal and rational roots. And then case 4, if d less than 0, let d is equal to minus k, where k greater than 0. Then the roots are x1 is equal to minus b plus square root of minus k by twice a. Minus square root of minus k can be written as square root of minus 1 into square root of k. And then square root of minus 1 is I. That's why you can write minus b plus I square root of k by twice a. Since I square root of k exists in this root, is an imaginary number. That's why his root is imaginary root. Similarly, x2 is equal to minus b minus square root of minus k by twice a is equal to minus b minus square root of minus 1 square root of k by twice a. Square root of minus k can be written as square root of minus 1 into square root of k, and then minus b minus I square root of k by twice a, because square root of minus 1 is equal to I. And this is also imaginary roots. And these two roots are also conjugate to each other. That's why you can write which are unequal and imaginary roots. Just you have to remember this. If d is less than 0, then the roots of the quadratic equation are unequal and imaginary roots. Let us make it clear more with the examples. Example 1. Find the nature of the roots of the equation 4x minus 1 minus x squared is equal to 0. Solution. The given equation is 4x minus 1 minus x squared is equal to 0. This equation should be written in its standard form. That's why you can write it minus x squared plus 4x minus 1 is equal to 0. Since there are two minuses and one plus, we should multiply both sides of it by minus 1. Then we can write it as x squared minus 4x plus 1 is equal to 0. It is not mandatory to write, but if you write it, then it will help you for not making any mistake. Now we should consider this equation with the standard equation ax squared plus bx plus c is equal to 0. If we compare x squared minus 4x plus 1 is equal to 0 with ax squared plus bx plus c is equal to 0, then the coefficient of x squared 1 is equal to a, and the coefficient of x minus 4 is equal to b, and the constant term 1 is equal to constant term c. Thus, we can say, comparing this equation with ax squared plus bx plus c is equal to 0, we get a is equal to 1, b is equal to minus 4, and c is equal to 1. Therefore, d is equal to b square minus 4ca is equal to minus 4 whole square minus 4 into 1 into 1 by putting the values of a, b, and c, and is equal to 16 minus 4 is equal to 12, which is greater than 0 and not a perfect square. If d is greater than 0 and not a perfect square, then the roots of the quadratic equation will be unequal and irrational. Let us see another example. Example 2, find the nature of the roots of the equation x squared minus 5x plus 7 is equal to 0. Solution. The given equation is x squared minus 5x plus 7 is equal to 0. It is already expressed in its standard form. That's why we should compare this equation with the standard equation ax squared plus bx plus c is equal to 0. In the same way, we get a is equal to 1, b is equal to minus 5, and c is equal to 7. Therefore, b is equal to b square minus 4c is equal to minus 5 whole square minus 4 into 7 into 1 by putting the values of a, b, and c is equal to 25 minus 28 is equal to minus 3, which is less than 0. If the discriminant d is less than 0, then the nature of the roots of the equation x minus 5x plus 7 is equal to 0 are unequal and irrational. Final confirmation. Just to remind you, if d is equal to b square minus 4ca in the quadratic equation ax plus bx plus c is equal to 0, why is d called discriminant? I think you know. Just see the answer. D determines the state and nature of the roots of the quadratic equation. That's why D is called discriminant. How can you obtain the integral nature of the roots of the quadratic equation? Answer: the integral roots can be obtained by solving the equation directly, because the nature of the integral root can never be obtained from D. If an irrational root of quadratic equation is given, then why is it possible to tell the other root of it? Because irrational conjugate roots appear in pairs in an equation. So if one root of quadratic equation is irrational, then the other root will be its irrational conjugate. The name of the topic for the next class is radical equations. Thank you very much. No more today. With this, I conclude here.